Okay, in this video we're going to talk about combining like terms, and there's a whole lot of vocabulary, so I hope you're ready. Okay, so the first one we want to talk about is a constant. Constant is a number that doesn't change. Anything that's constant, you know, doesn't change, so that's why it's called that. So a constant is going to be a number. Just keep that in mind. Constant is a number. Next term is variable. A variable is a letter that stands for a value that may change. Okay, so variable is a letter. Constant is a number. Variable is a letter. These are both terms you've heard me use in class. Next, we have something called a variable expression. This is a mathematical sentence containing constants, variables, and operational symbols. What's another term for variable expression? An equation. Again, stuff you've heard me say in class. So, what is a term? A term can be a constant, a variable, or the product of the two, such as 7y. 7y is a term, 7 is a term, y is a term, 7y is a term. So term can be lots of things. When we look at something like 7y, the number 7 is also what we call a coefficient. So coefficient is the number that sits in front of a variable. So we have some new words so far. We have constant, which remember is just the number, a number by itself. So like 7. Variable, which is just the letter, so like y. Variable expression is a math sentence containing constant variables and symbols, so like x plus 2. And then we have a term, which can be a constant, a variable, or the product of the two, such as 7y. And then we've learned the number that multiplies the variable is a coefficient. So in the term 7y, the coefficient would be 7. Okay, important things for you to remember. We're getting a little further. So what are like terms? Well, we know what like means. If you dress alike, it means that you have on the same outfit as someone else. So like terms mean are terms that have the same variables. Okay, all constant are like terms. So if we have two variable expressions and we're combining things, if there's a constant such as a 10 and a 7, those are like terms. You can combine them. So when you're combining like terms, you want to be sure that the plus or the minus or the positive or the negative in front of them go with it. Okay, so let's try some. We have 3x plus 9 plus 2x minus 8. So doing this, we want to combine the like terms. So what are our like terms? Well, here we have 3x and 2x. Those are like terms. So 3x plus 2x is going to give us 5x. Now, we don't have to use our exponent rules. We are adding here. We're not multiplying or dividing. So we just add 3x plus 2x. It becomes 5x. Now, we have 9 and we have negative 8. Remember, whatever the plus or minus is in front of it goes with it. So 9 and negative 8, think back to your integer rules, it's the same as 9 minus 8, becomes 1. So when we combine these like terms, our answer becomes 5x minus 1. Okay, let's look at some more. Okay, next we have 10 plus 12y plus 2 plus 8y. So we have 10 plus 2. Those are both constants. They can add together. 10 plus 2 is going to give us 12. Then we have 12 at y. That's a positive. Minus 8y. That's a negative. 12y minus 8y gives us positive 4y. Now, when we have anything with a variable, we actually want to write this first. So I'm going to rewrite this like this. That's the proper way to write it. But as you know, addition is commutative. So if you wrote 12 plus 4y on a quiz, I would not mark it wrong. I would write the correct answer, but I would not mark it wrong. All right, so let's take this a little bit further. If you have exponents such as 2x squared, they must be the same. So let's look at this one. We want to combine like terms. So this one has 2x squared plus 3x plus x squared minus 5. Remember, they have to be exactly the same. So in this one, I have 2x squared plus 3x. These are not like terms. This is an x squared, this is a 3x. They cannot be combined. However, this 2x squared and this x squared can be combined because they are the same. Now, so I'm going to take 2x and I'm going to add it plus x squared. Remember, what's always in front of an x squared, or a number, what's implied, we have that 1. So this becomes 2x squared plus 1x squared, and that gives us 3x squared. Now, we want to do this in descending order. We have a plus 3x. There's no other x's, so I'm just going to write plus 3x. Then we have this minus 5. There's no other constant terms, so I'm going to write minus 5. And that's what we're left with when we combine all the like terms in this sequence. Okay, now we have one more. We have 5y squared plus 2x squared minus 3x plus 1. So let's start with our y squared. There's no other y squareds, so we have nowhere to put it. And I don't have any space there, so I'm going to come down here. Okay, so what's next? Plus 2x squared minus 3x plus 1. I have no other 2x squareds, so I'm just going to write it down here and bring in that positive with it. Okay, next I have a minus 3x. There's no other x's, so it's going to come with it. And then I have a plus 1. I have no other constants, so it's also going to come with it. So in this case, I had no like terms that I could combine in my variable expression, so I just rewrote what I started with. And yes, it is necessary to rewrite what you start with so that I will know that you actually did look at the problem. Okay, so study this and be ready to practice some more in class tomorrow.